students. So in today's video we are going to discuss a very special case about how to find electric field because of arc. Right? There is an arc and on which charges are being continuously distributed and we are being said to calculate the electric field. See, this is how the diagram looks like. Let us say this is your x-axis, this is your y-axis, this is origin. See, this is an arc on which charges are continuously being distributed. Because of these charges, we are being said to calculate electric field at origin. What is the electric field because of this arc at origin? Okay, fine. Let us say the end of the arc, that means the subtends an angle theta. Okay. So again we'll follow the same procedure. We'll consider a charge dq and we'll write the formula of electric field because of a point charge and then we'll integrate. Okay. So let us take a charge dq. This is the charge dq. Suppose let this angle be, you can say any angle, let us say phi, and this be d phi. Make it clear, phi is this angle, d phi is this angle and theta is the total angle. Clear? Okay, so this positive dq will have the electric field in this direction because we had already studied that for a positive charge electric field will be away from the point, right? So electric field will be in this direction. Done? If this is phi, this angle will be phi, vertically opposite angle, right? See, I have considered a charge dq which subtends any angle d phi, and because of this charge dq, the electric field will be along this direction, right? Okay. Now there will be two components possible for this electric field. This will be dE cos phi, dE phi, dE cos phi. This will be dE sin phi. Clear? So now this is the x component of electric field, this is the y component of electric field. Let us integrate this and integrate this. So after integrating this we'll get x component of electric field and here we'll get y component of electric field. Then we'll add those two components. So that will be the resultant electric field because of this arc. Not resultant, this will be the electric field because of the arc. Because for resultant we have to find the magnitude. Okay, fine. So let this distance be r, radius r. Charge is dq, distance is r. We are told to find the electric field at the origin. So for a point charge, electric field is kq by r square. Right, so electric field dE is equals to kq by r square. Right, kq by r square. See, this is a point charge dq. At a distance r, we have been said to find the electric field. So electric field is kq by r square. But instead of q, I am having dq. Clear? Okay. K by r square. Yes, dq can be written as dq can be written as lambda into dl, right? Lambda into dl. What is dl? dl is this length of arc, this part of length of arc. This is dl. Okay, so this dl is this much part, right? Fine. So lambda into dl. Still this dl which is a part of arc can be written as radius into angle. So this can be k by r square into lambda, length of arc is equals to angle into radius. This r gets cancelled. So finally dE is equals to k lambda upon r d phi. Okay. So now let us find the x component of electric field. So x component of electric field will be obtained by integration 0 to theta, because the whole angle is theta. Clear? This end subtends an angle theta. So 0 to theta dE cos phi minus I caret, because it is along negative z. It is along negative z. Clear? Clear? So E of x will be 0 to theta. What is dE? K lambda by r cos phi d phi minus I. Simple. I have just substituted the value dE. Okay, so now k lambda by r can be taken outside. Integration of cos phi will be sin phi, of course, 0 to theta minus I caret. Apply the limits. So this will be minus k lambda by r sin theta I caret minus sin 0, that is 0. So this is x component of electric field. Okay, now we'll find the y component. We'll find the y component of electric field. So y component of electric field will be obtained by follow the same procedure. But now instead of writing cos, we'll need to write sin. Okay, so dE sin phi minus j, 0 to theta dE means k lambda by r sin phi d phi minus j. So this will be minus k lambda by r 0 to theta sin phi d phi j caret. What is the integration of sin phi minus cos phi? Integration is minus cos phi. So this minus and minus will become plus. So it is finally k lambda by r, this will be cos phi j caret 0 to theta. See, sine, integration of sine is minus cos, this minus and this minus will become plus. Okay, now apply the limit. So this is k lambda by r cos theta minus cos 0. See, now cos 0 is 1, so you need to apply both the limits, upper limit and lower limit. This is your y component of electric field. Clear? Okay, so now what will be the net electric field? What will be the electric field here? So electric field here will be x plus y, right? So E of x, which is minus k lambda by r sin theta I plus k lambda by r cos theta minus 1 j caret. You can take k lambda by r common. So this is minus sin theta I plus cos theta minus 1 j caret. Okay. So this is the electric field produced at the origin because of this arc. Right? You can take this as general formula. Now we will solve the questions with the help of this formula. Clear? If you are even though you are not remembering or you are not knowing this derivation, then just remember this formula. It will work out. Clear? Students are generally not advised to do this derivation. Clear? Okay. So now this is the general result, k lambda by r minus sin theta I plus cos theta minus 1 into j caret. Now see, we can apply this formula in this kind of questions, in this type of questions. Like, what if we have been said to calculate the electric field due to this? Of course, we will have the method also to solve this question, but now this is a semicircular arc of any radius r, and you have been said to calculate electric field at O. You have been said to calculate electric field at O. See, this subtends an angle 180 degree. Theta will be 180 degree. Charges are up to 180 degree, 0 to 180. Substitute here. Substitute theta equals to 180. We will have k lambda by r minus sin 180 I plus cos 180 minus 1 j caret. Fine. We have just used this formula and we have substituted theta equals to 180 degree. Sin 180 is 0. So, this part will be cancelled. So, now this will be k lambda by r bracket. What is cos 180? Minus 1. And this is also minus 1. So, this will be minus 2 j caret. So, your answer is minus 2 k lambda by r j caret. Clear? Clear? Now, if the question is this way, find the electric field over here, then substitute theta equals to 90 degree. Substitute theta equals to 90 degree. Of course, we will solve it with the method also. But if you are knowing this formula, you can solve the question in very small time, short time. Okay, fine. So, now if this is the question, then you will need to substitute theta equals to 90 degree. Theta equals to 90 degree. Clear? Okay. Now, similarly, this kind of questions can be solved. If this is the case, then substitute theta equals to 3 pi by 2, 270. If charges are distributed up to here. Okay, fine. Now, we'll also understand how to calculate the electric field with the help of the method. That means, if this way charges are distributed and I am not knowing the formula which we had derived, then how to solve this question? What if this is the way charges are distributed, half positive, half negative, and we have been said to calculate the electric field here, here. Already we are knowing the answer of this question, right, with the help of that formula. But even if suppose we are not remembering the formula of arc and the question arises, then we will also learn the method how to solve the how to calculate the electric field for this kind of shapes in the next video. Okay, clear? So, in the next video, first we will solve this kind of questions and then we will switch on to next topic.